Okay, so as we continue to adjust to a new normal, let's look at adding fractions, because adding fractions is something we're supposed to do. So we're still going to run off the idea of these fraction strips from before, so hope that's helpful. Uh, Adding fractions starts out really easy. Let's see. Oh. So if the denominators are the same, this is fairly straightforward. To be clear, here's what we mean. Oh, wow. If we have 1/5 and then inexplicably there are two other fifths, I'm pretty sure that this 1/5 plus those 2/5, that's 3/5. You should think to yourself and be able to answer. Right? Because that's the right wrong answer. That's we added the numerators, we added the denominators, we got 3/10. You should think about how you would explain to a small child why the answer is not 3/10. Why is the answer 3/5? Pause, hit the pause button, write down in your notebook, why isn't the answer 3/10? Why must it be 3/5? And don't fall back on, well, we just keep the denominators the same. There has to be a reason why we keep the denominators the same. What is it about the model that makes clear that the answer is not 3/10? If you're interested, you should figure out what that is. Okay. We don't have little strips that model that, but I think you have the idea. Incidentally, let's do bad things. Let's do bad things. This drove people nuts when I was a kid. 1 2/5 plus 2 4/5, and what the heck is that, and who can even know? Like 1 and 2, that's pretty easily 3. 2/5 and 4/5, that's pretty easily 6/5. And then some teacher is going to say, you can't do that. Well, that's true. You can't do that. That's an improper fraction. So what do we do instead? What do we do instead? Well, when we've added in the past, we've added from right to left. We've added in this direction. So 2/5 and 4/5, that is 6/5. 6/5 is too big to write here. So we ask ourselves, what is 6/5? Well, 6/5 is 5/5 and one more fifth. So this is a whole. And so these are where your wholes go. It is a very similar idea to the carrying when we added whole numbers and the like. 2 and 1 and 1, and that's it. You might want to think about how you would add 3 2/3 to 2 2/3. You might think about how you do that. Take a moment, work it through. Make sure you can add 3 2/3 to 2 2/3. Make sure that you get 6 1/3. Okay. But what happens if the denominators are different? What happens if the denominators are different? What happens if you've got your 1/4 and you've got 2/3? Here, we'll even run them together like this. How long is that? How long is that? Well, I can't add those together the way they look right now because I don't have a comparison. But if we bring this in and we recognize that 4 of these is that 1/3, and another 4 of these is another 1/3, and let's see if I can screw this up sufficiently. 3 of these. Hey, that worked pretty decent. Hey, how about that? I could make it on YouTube yet. We can get a number of 12ths here. We can get a number of 12ths here, and we can compare in this way. So there are 1, 2, 3, 4, 5, 6, 7, 8 12ths in the 2/3, and there are 1, 2, 3, 3 12ths in the 1/4. And so it appears that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 12ths in the 2/3 plus the 1/4. What's the process? The process is I want to add fractions the way I've been adding fractions. And to add fractions the way I've been adding fractions, the denominators have to match. And in the 1/3, 1/4 case, the denominators don't match. So we make a way for them to match. We use the equivalent fractions that we touched on last time so that the denominators will match. The pieces here are 4 times as big as the pieces there, so it takes 4 times as many of these. The pieces here are 3 times as big as the pieces there, so it takes 3 times as many of these. And once you have 8 12ths and 3 12ths, it's really easy to add together. You may, on your own, add 2 fractions. Make sure that you can add 2 fractions. Make sure that you can take the models and use them well and combine those fractions. Hit the pause button. Do it. You didn't actually do it, did you? You didn't. You didn't. Don't even know what to tell. Don't even know what to tell you about that. There's 1/2. There's a 1/5, and we'll clone it. What is that? Well, so we just need a bunch of these, right? We just need a bunch of these. 1/2 is the same as, right? Right? 1/2 is the same as, right? And then 1/5 is the same as right? And 1/5 is the same as, right? So what do we got? Well, this 1/2, he played one. Oh, I'm so sorry. And then this 2/5, right? So we find a cut. Really, there's no brown? This is close. This'll do. So this 1/2 is the same as 5/10, and this 2/5 is the same as 4/10. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 9/10. The model seems to support what our arithmetic seems to indicate. Now, I mean, it's a hop, skip, and a jump to say let's subtract. What's a good common denominator here? Right, that's a good common denominator. 1/12 is the same as 1/12. How many twelfths are the same as 1/3? Okay, so what's this? If we have 4/12 and someone takes 1/12 away, I sure hope that's 3/12. By the way, 3/12, it should be said, reduces to 1/4. Okay, okay. You should take a moment and make sure that you can subtract. Oh, let's subtract. What would be terrible here? 5/12 minus 3/8. That would be terrible. Take some time. Make sure you can do that. Make sure you can figure out what a good denominator is, what are equivalent fractions, how do we subtract those fractions. Hit the pause button. Do it. Did you actually do it? What's the common denominator? Right? That's the smallest number that 12 goes into that 8 also goes into. Pieces are twice as big here as they are there, so it takes twice as many to equal the 5. Pieces are 3 times as big with the eighths as they are with the 24ths, so it takes 3 times as many. And that's your answer. That's your answer. Well, how about that? What happens with that? I feel like a good common denominator here would probably be 15, right? Like I feel like that. And I feel like the pieces here are 5 times as big as the pieces there, so it takes 5 times as many. And the pieces here are 3 times as big as the pieces there, so it takes 3 times as many. And then, well, I get a little nervous because I can't take 6/15 from 5/15. Can't do that. Well, what did we do when we were subtracting whole numbers and we couldn't subtract this from that? We looked over here and tried to take something away and bring it over. Well, what if we tried to bring 1 away? If we took that 1 away and we brought it over here, that 1 would be 15/15. And 15/15 plus 5/15 is 20/15. So this is 2 and 20/15. This is 2 and 6/15, and we're going to subtract. So this is now doable, and we've got it. So the borrowing idea remains with us. We remove something from here and bring it over there in an equivalent way, in the same way that we took away a 10 and wrote 10 in the ones place. We take away a 1 and we bring the 1 to the over 15's place. But to do that, we do it as 15 over 15. Okay, that is all that I had planned on adding and subtracting. There's obviously tons of practice that we can do. You can take your favorite fractions and add them. You can take your favorite fractions and subtract them. But in terms of an explanatory video, these are the big pieces in place. So adding and subtracting fractions, we want to do things with common denominators. It is so important to know why. It's so important to have pictures that explain why we use common denominators. I hope that this helps with small children, and I will see you next week when we multiply.